device is extremely important. So if you have, for example, a device that has a constant voltage, let's say with a battery charging type of things, if you change the series resistance, it would decrease the whole operating current, less performance of the device. So if you take a plot, for example, and you look the performance, okay, the device, okay, between lower and higher resistance in here, you're going to see that actually what happens if this is much different by a large. So what we want to do is maintain as lower possible resistance of the devices or the actual system itself as possible. Okay. Leakage currents in here associate much more for the actually parallel types of resistances. Why am I saying all this stuff? Because what happens is when you're going to install a panel or a system for the first time, okay, or the second time, you're going to encounter these kinds of problems, and you're going to say, why it's not working right? And somebody's going to come up there and it's going to start tracing wires all over the place, and you're going to see all kinds of things that you're doing. And he's going to say, this is too long, this is too short, you should have done this one this way, you should have done this thing the other way. And you're going to say, gee, I should have paid attention. Trust me. Okay. Obviously, if you have any kind of shunt resistor which is parallel, it's going to have an effect of what? On the performance curve, the IV curve, and obviously it's going to affect what? The actually power up here. If you decrease the shunt resistance, it reduces what? The fill factor and efficiency, lowers the maximum voltage and current, but it doesn't affect anything that is related to what? To the actual short circuit. If you decrease the shunt resistance of the system over time, you can have what? Short circuits in what? On the cell in here, and you might have modules that are not working well, or not working well, or what? Or ground faults. Some of the inverters, they check for these things. So if you look at the actually performance of the voltage current characteristics in here, it gives you the nothing in this particular, in the actually resistance that would affect the short circuit current. Short circuit current maintains the same, because remember what do we mean? Short circuit current is what? The actually shorting of the actually leads itself. Okay. Now, a couple of things now. The solar irradiance, remember what do we mean by solar irradiance? The amount of radiation that you get into the panel. If you change the solar irradiance, it has no, or not small effect on what? On the voltage. What does that mean? That means that if I take a panel and I shine 1,000 watts per square meter, and I take the same panel here and I shine, let's say, 800 watts per square meter, the voltage won't change. The factor won't change. Okay, on the voltage. However, what is that going to affect on? The current. So if that's going to affect the current, what else is going to affect? The power, right? So the amount of irradiance, okay, has no effect on the voltage. Very small. It might drop a little bit in the open circuit voltage, okay? So, but it will have tremendous amount of effect to what? Of the current. That's why, because that is one of the areas that a lot of the manufacturers up there try to take care of, that if I do lower at some point what? The irradiance, not to affect the current. How are we going to do that? I don't know. Okay. So the current of a device, okay, increases proportionally what? With the amount of incident solar irradiance, okay? Since the voltage remains what? The same, then the what? The power increases what? Proportionally. And if we take a look at it, you can see in here the voltage versus what? Irradiance. So this is solar irradiance that we 200, 400, 600, up to 1,000 up here, and this is the current. So as the current increases, so does what? Does the power. So at this particular point, when the actual what? Current is a little bit, you get no power. As it increases up here, we get power. You can see this is actually what we call it a proportional increase. So basically what we were saying is, listen, more irradiance, more current, voltage is the same, and what happens? I'm going to get more power in here. So if we look at here, we have actually a plot, a representation for a particular module under different conditions of what? Of irradiance. So we have 250 watts per square meter, 500, 700 watts, 1,000. That's a practical representation. This one is just a description, but this one is something you people should understand, and that's why the manufacturers, they put it in the back of the book in here. So it says to you, look, you're going to go sell this job to somebody, and you're going to be talking to them, and you're going to say, look, I don't know how much sun you're going to get. How are you going to prove that? You get a pyrometer, and you measure it, and so forth. But however, under these conditions, I can define you of how much power I'm going to get, or what, out of this particular module, because I have the information supplied by the manufacturer on the different forms of irradiance. And you can see here that the power associated at 250 watts per watt per square meter, it's much, much less than the one that you get at what? At 1,000 watts. Manufacturers now start putting this. So if you look at this electrical characteristic plot in here, it gives you this kind of representation associated with that. Unfortunately, for some reason, this is very difficult to read, but that's what it is. Any questions so far? So power depends a lot on solar irradiance. No effect of the irradiance to the voltage, open circuit voltage. No effect, very small. Now, what are the other environmental things? You want to break? You okay? Or you want a 5-minute break? Yes? Keep going. Bruce?
5-minute break.
5-minute break. Okay, take 5-minute break.